not going to cover too much. The point is just to get you guys warmed up, and then we'll go straight into the project.
Decades ago, the Gregorian calendar changed the game. It set the global standard and became internationally the most widely used calendar today. As a result, we've become so accustomed to this grid-like, boxy calendar design that we call modern. So we asked ourselves, how do we take the modern calendar design and make it modern again? So we did just that. The spiral.
Spiral calendar redefines the way that people look at change. The shape of the spiral is a unique one which conveys a feeling of infinite possibility. Users are able to view their upcoming event in a three-dimensional way on a two-dimensional surface, which was unimaginable in the past. We made the gesture so intuitive so that all the actions just feel natural to the users. Spiral will not only revolutionize the way we visualize the calendar, but will also set a standard as how we visualize user interactions.
Exclusive beta testers were invited to explore Spiral plans as well, allowing them to experience the vision behind Spiral firsthand on a tabletop display. By logging into their own calendars, these testers encountered their own events in a novel, paradigm-shattering way. Testers found the application's multi-touch interaction and event display features to be intuitive, and fell seeing their own events displayed on such events. With the extensive positive feedback we received, testers often asked us when Spiral was ready to move down. Basically, they're saying, we want this, and we want it now.
Spiral is an application that strives to think about moving forward while being able to move forward. With Spiral, we're taking the very latest in web technology and combining it with the greatest in interactive hardware to visualize something that feels familiar, yet is completely new at the same time. Together, we're creating the design of the modern calendar again.
So yes, our project is Spiral, and it's essentially a revisualization of the modern calendar, and I'll get into detail about that a little bit further on. But just a quick overview of everything. We'll all introduce ourselves to you. I'll talk a little bit about the motivation and design behind Spiral, while the others talk about previous work. And then Stephen will talk about implementation, and also we'll follow with a small, quick demonstration. Then the other Stephen will talk about user study, and we'll talk about feedback results from exhibitions, and as well as future work. So my name is Ruiz. I'm a senior, and I'll be graduating in 1.5 weeks. Exciting. So. And basically my focus on this project was on the UI and visualizing all the data in 3D space. That was my work.
I'm Stephen Tenai. I'm a graduating senior as well. For this project, my focus was mainly on the back end. That's what I really like working on throughout my career. So really like working on the back end and working behind the scenes, trying to make sure all the Google authentication works out and everything like that.
Stephen Chen, and I'm a senior as well. I'm basically working on all the touch gestures and investigating like how to make it more effective and more intuitive to the users. So yeah.
So as I said earlier, this is a revisualization of the modern calendar. So when you think about today's calendars that you find in smartphone apps or even traditional calendars, they're kind of conform to this grid-like boxy display. So also at the same time, we wanted to create something new that kind of keeps up with the way that technology and interfaces evolve. So we thought, how do we take this traditional plan that everyone is so used to, everyone's so familiar with, and just put it into something completely new and represent that in a new way. So, actually, I'm done. So.
And sort of leading to our motivation, our target device for this application was the Microsoft Perceptive Pixel, which is a tabletop computing device. previous work has been done on tabletop computing services. They found that allows for easy collaboration between other people, and work has been done on trying to make it easier to develop applications for tabletop surfaces, as well as guiding interaction based on touch versus normal mouse and keyboard interaction. Gesture recognition has also gotten a lot easier to implement, at least on a base level, using lighter and more quicker algorithms that don't require super advanced computing topics to be known to developers.
In our previous work, we look at is how do we present time series data on Spiral. So basically, there's a lot. I read like 2 papers about it. So basically, time series data have these attributes that it repeats itself like always. So if we put on Spiral, we can visualize it in a different way, which is so next, I'm going to talk about implementation. So our application is basically web-based. Because the reason for web-based is that it can cross multiple platform. Because we don't have to do a specific one for iOS and a specific one for Windows service. And the other one, because like Steve just said before, we're using the Microsoft successor itself. So touch is a big part of it. We're trying to use touch gestures to make it easier for users, so that will require a lot of learning curve and stuff like that. And also, Google Calendar is the most common thing we use now, like most people use to write down use for their calendar app. So that's why we decided to use Google Calendar. So there are some API calls from Google Calendar. We can directly get information or data from user. And basically, there are 3 main frameworks, and I'm going to talk about each one of them. One is Node.js, is more like the backend part of it, and also for the visualization part, 3.js, and also Hammer.js is a JavaScript library that used for touch gestures. So Node.js is basically like it's an event-driven JavaScript. So it's like a tree. It has a basic tree structure. So from the top nodes, you're gonna look at the possible next event, and you go to the next node and see the next possible operations. So after other operations are run out, then you go back to the original node. It's open source. It's MIT licensing. So basically, it's a permissive licensing that means you can use any way you want. Anyway. And Hammer.js is a touch library with JavaScript. So it's based on Element Messenger, which is it's like Element Messenger but just for touch. And you have some feature implemented based on that, like how long the touch has been done, and how far the distance has been moved, the finger has been moved, stuff like that. So basically, just it's a touch library we use to implement all the gestures, and it's also a And the last one we use 3.js is a 3D library, which is just like basically like a web OpenGL, and we use that to draw spirals, put the labels on it, and we play a lot with it to make it more 3D-ish to the users. And basically, we use perspective camera. What that means, we fix. So depending on it's kind of like how you see items in real life, how far away from the object. So yeah, if you can see the real demo, we can show you like how it's being used. And, yeah.
Alright, so I'll walk you guys through a quick demo of the application. So here you can see it running in real time in Chrome. This is what we use. This is exactly what we use for our user studies. The target device, as mentioned earlier, was from the Microsoft Perceptive Pixel, basically a 55-inch touchscreen, and just lots of fun with it. So this is what our user study was done on. So basically what the user would do, they would sign in using their Google account. You can see I'm already logged in using Google. It'll just tell you what data it uses. All our users have to agree with this before they can use the application. So once logged in, it takes a little bit of time to just gather all my information. but just gather all my calendar data, and you'll be given a short tutorial on exactly how to use it, but I'll walk you through it real quick. Okay, so basically the app is, once logged into the app, you're introduced to 4 different spirals, and the way you navigate between each of them is you just swipe left and right with one finger. So starting off, this is the year spiral here. So initially we had all of the users' data represented on this spiral. One rotation is a single year. So having 5 years and thousands and thousands of events on a single spiral is not pretty to look at all. So we split it off into months, so it's easier to view. You can tap on any month that you want, but in order to move forward or backwards in time, you can pinch to zoom to move forward. Which is pretty useful on the table, is that you can do a 4-finger winding motion. So you'll place 4 fingers on the table, and you can wind around the center of it in order to move forward and backwards. So let's say I want to get a more precise view. I could go into, I'll go into March 2014. So I can double tap on the March 2014. It'll go into a monthly spiral, which is segregated in 2 weeks. So you can see the week time frames there. So I can go into a more accurate time point. And so basically, once you get to the weekly spiral, you can actually start to see my events. This is my actual class schedule, just right here, no one can really see. But you can, as you get to this point, you can actually start seeing the trends and patterns in your actual weekly schedule. Not just your weekly schedule, but let's see this one here. But even your daily patterns. So here at A&M, classes are Monday, Wednesday, Friday, also Tuesday, Thursday. So you can kind of see the pattern going between each iteration of the loop. So you can obviously see where I have the event schedule. That's kind of the time those blank areas are kind of the evening hours, nighttime, etc. So that's a quick demonstration of the UI. So switch back to PowerPoint. And so each of us will talk about the challenges that we encountered while making this application. Starting with Steve.
So, the main challenge in the back-end that I faced was authentication using the OAuth 2 schema. Our initial design had the authentication and API calls happening on the back-end side, trying to use the Google API client for Node. But that client is in early beta and it's undocumented, so it's not as easy to use as normal other Google APIs. And a lot of the authentication methods weren't documented very well, and even using other modules didn't really seem to help. Once we got authentication working on the server side, I was then blocked by cross-origin resource sharing, which is a JavaScript thing that's cross-site scripting attacks. So the easiest way to get around doing that was what we did is we moved authentication and all the Google API methods into the client browser side and cleared up those issues.
So the issues that I encountered when creating the innate space or UI was one of them was making the spiral infinite. So you could theoretically infinitely go down, keep pinching or keep winding, and pretty much the spiral would never end. So keeping that just well displayed and efficient was a little bit of a challenge. Also connecting time with space as well. When creating these events, they have to line along the spiral properly. Doing that in a 3D environment can still be pretty tough. So pretty much we do have an algorithm implemented which does make very accurate calculations as far as where events are displayed, the angles, the size, etc. And also another challenge is the legibility. When you create a 3D UI, it's really important to make sure that the colors, text, everything is clearly visible. It can be really tough to do in 3D space. One of the challenges, labels was a huge challenge. Initially, we had our labels drawn and rendered in 3D space, so there was actually 3D text on every single event. It proved to be very inefficient and just a lot of issues from along the way. So we switched to an HTML-based label system, so all we had to do was just cast or project it onto the actual event itself, and that proved to be a lot more efficient.
One thing you mentioned is that all the library we use is no longer than 3 years old. So basically they are now well documented, so we have to do a lot of investigation and try to figure out what's going on. And as far as the touch part, first thing is the rotation. So the rotation is like how we reflect how long the finger has been moving to like the rotation of the spiral. So the way to solve it, I use a cross product to calculate the angle it moves, and every calculated angle it moves, then reflect a rotation on the spiral. And the other thing is multiple finger input. So if you have multiple finger, you're trying to swipe. You use one finger swipe left and right. Sometimes before you recognize it as it also recognizes a rotation gesture. So to separate it, we use 4 fingers and 1 finger. We use mobile touch since we're using a big tablet, so 4 fingers make more sense to do something else.
Now, go over the user studies. So our user study was an IRB study, and the goal of our was that we were trying to evaluate how well the user interaction was with our application. As our goal was to make the user experience a lot better and find something new. With the use of privacy matters, initially our application was going to have interact with their user credentials on the backside and on the server side. At least they would have to know the access token. But thanks to our design change, the way we went, all of that data is in the browser, and the server never sees anything. The server is just a lightweight web server now. And so the only user data that's ever stored is data that's being stored by the user's browser. And for the user study itself, we used incognito mode for Google Chrome, which deletes all that data upon the closing of the browser. So the procedure for the user study was that we gave them a pre-test questionnaire to make sure that they were active users of Google Calendar, since our calendar relies on Google Calendar for data, as well as how familiar they were with touch devices. And then we had directed them to the Perception Pixel and had them interact with the calendar, swiping between calendars, rotating calendars, and pitching to Zoom. And afterwards, we asked them to complete a post-study questionnaire, which is kind of ranking the application on usability, learnability, and how practical it was both now and in the future. And as from the results from that, we got the usability was the thing on a scale of the Likert scale of 1 to 10, averaged around a 75% because of the Ruiz and Steve both kind of mentioned the 4-finger gesture to rotate through calendars. The touch lever sometimes would actually have trouble picking that up and would think it's a different gesture midway through, and so led to a little bit of issues. But
and so basically, we went to a few exhibitions. For SRW, we placed second, which was we were very proud of that accomplishment. Also, we presented for a short time at the IAP banquet, and I got good comments from a lot of professors, including Dr. Schaefer himself. So I feel pretty honored about that. And also, we went to the college engineering showcase, and we received so many overwhelming suggestions about how we can better represent the data, or even other implementations. A lot of sponsors said things about, it would be useful for product management, checking vital patterns, etc. And a lot of them, just spoke to us and like, seriously, guys, you should probably like tracking this, So the response was overwhelming. So as far as our future work goes, we're going to take those considerations, the other implementations of data. We want to probably turn Spiral into a JavaScript library. And open source it so that everyone's free to use it, tinker around with it, even help us improve on it as well. So that's it. Are there any questions at all?